Okay, so there we go. So there's question number 1. So I'm doing this one first off. Can you do that one? Try that one real quick. So graph it. They want you to graph it. So pretend it was the real exam. See how you're doing. So what do you need to do first? Period is 2 pi over b. 2 pi over. Now what's b? What do we mean by b? Yeah, this is like a and this is b, the number next to x, huh? Pi over 3, is that good? So now, what do we do? That's kind of weird looking. You know, fraction on the bottom flips up because dividing is upside down, multiplying. So that's 2 pi times 3 over pi. Is that good there? And then, this is over 1. These cross cancel. 2 times 3 is 6. So the period is 6. And what is the phase shift? Negative c over b. And what's my c? 0. It's whatever number, it's plus 0. It's any number that's added inside the parentheses. We don't even have parentheses. 0. There's nothing there. So it's minus 0 over pi over 3, which is just 0. 0 over anything is just 0, isn't it? Good so far? So, okay. So let's do that. So therefore we say, okay, so now where is this graph? So this is where it's going to start. I'll just bring it down here. It's going to start at the phase shift. It's where they always start, which is 0. And it's going to end. Where's it going to end? At the starting point plus the period, because the period is how wide it goes. So so the starting point is 0, the period is 6, so it's going to end at 6. So this graph, when we draw it, is going to start at 0, end at 6. We'll start here at 0, end at 6. So I've got the width on it. Good so far. Start at 0, end at 6. Okay. And so what I'm going to put between 0 and 6 is a cosine graph. What's a cosine graph? The upside down U-shaped. In fact, let me just go to this screen and let me just write that up. So it'll be on the YouTube also. Summarize, well, here, let me just graphing sine and cosine. So just have this down. Graphing sine and cosine. So we know sine starts in the middle, goes high, goes low, back to the middle. Cosine starts high, goes low, comes back high. It's a U-shape. That's sine, cosine, and we know the period is 2 pi over b, and the phase shift is negative c over b, and the graph starts at the phase shift. And it ends at the start plus the period. Okay, so there's the facts, how you graph sine and cosine pretty much all the time. So getting back to it, so we know we're going to go from 0 to 6. 0 to 6, and I'm going to put a cosine graph in there, which means I'm going to start high, go low, come back high, do a U, but what? I bet some of you know, huh? Why? It's not going to really be a normal U in here. Why not? Yeah, good job, because of that negative. What is that negative in the front going to do? Flip it upside down. Remember, negative in the front? Negative. It says negative. Negative in the front. Flips it, huh? For any of these graphs. So instead it's going to start low, end low. Instead of starting high, ending high. Just going to do that. And what's the half? That just means it's only going up to a half and down to negative a half instead of like it normally does 1 and negative 1, huh? But it's an upside down U shape between 0 and 6. Am I good? Questions on that one? Now, I still want to show you how you're going to identify that on a multiple choice test. We're going to get to that. I'm going to get through this thing and try to get to that. If I don't, that's already on YouTube. That other one's already on YouTube that I did in years past. Okay, let's... Okay, so try that one. So all the same stuff. Let's see what you can do. Gotta find the period in the phase shift, start and the end. Yeah, good question. The A is the 5, as you know. The B is the 3, and the C is the minus 2 pi. Yeah. Yeah, the B is the number multiplied next to x, and the C is the number added and subtracted after the x. On that. So 2 pi over b, 2 pi over 3. So the period's 2 pi over 3. And the phase shift, negative c over b, negative 2 pi over 3. So positive 2 pi over 3. Did y'all get that okay? Ever see the double negative thing? Because the formula is negative c over b, and then the c itself is negative 2 pi. Right? So it ends up positive. All right, so that tells you about the start and the end. So it starts at the phase shift, positive 2 pi over 3. It ends at the start plus the period, which is the same as the start, which comes out to be 4 pi over 3, doesn't it? Right? So it starts at the phase shift. It ends at the start plus the period. Yeah? Okay. And so then I go to the graph. And I say, okay, I'm going to put a cosine graph here, and it's going to go, let me shift that around a little bit. It's going to go from 2 pi over 3 to 4 pi over 3. Like that. I probably didn't draw that to scale very well, but whatever. I don't like that. 2 pi over 3 to 4 pi over 3. Okay, and, right? Yeah, I should draw that a little better. So, boom, boom. So 2 pi over 3, 4 pi over 3. And what's it going to do between 2 pi over 3 and 4 pi over 3? It's an upside down cosine, isn't it? So it's a U shape, so it's going to be upside down. You start at the bottom, go high, come back to the bottom being negative 5, the top being positive 5. It's an upside down cosine. Is that good? On that?
I have a question.
Yeah.
So where it says end, say it was negative 2 pi over 3. Would it be 0 then? Because the positive 2 pi over 3 plus a negative 2
Okay, so give me which start you mean and which end you mean.
So start would be positive.
Be smaller because you always add the period.
Okay. Well, I think I'm thinking the phase shift then. So if it wasn't a positive, if it was a negative.
Negative what?
2 pi over 3.
For the start?
Mm-hmm.
Okay. Okay, so you want a
start is.
You want a phase shift that's negative, you're saying.
Yeah.
Right? Okay. And the period's always going to be positive.
Yeah.
So that was 2 pi over 3. Then it would start at the phase shift, negative 2 pi over 3, and end at 0.
Okay, that's what I was
Yeah.
thinking. Okay.
That's right. Yeah. Because you just add those together, right? For the ending. That's right. We good there? Does that make sense? Yeah.
Why did the phase shift become positive?
Yeah, because the phase shift, see how the formula has a negative c over b, and then c itself had a negative. Double negative, positive. Now be careful on that. All that little negative stuff gets people. So is that good? Now the real trick on that, I mean that's the right answer and that's all good. On the multiple choice test, do you realize there's actually going to be another u here? We're just finding where the main one has moved. But remember, they go forever, right and left. And so that's what's confusing, is you've got this right here, and you're right, this is totally it. But then on the test, you look at the multiple choice answers, and there's one right here. And you're like, uh-oh, is that right? Is that not right? Remember, they go forever, don't they? Mm-hmm. You're just finding one of them. So just make sure yours is right, and don't let other things bug you. Just look and say, is there a u between, an upside down u, between 2 pi over 3 and 4 pi over 3? If so, great. Grab that option. That's the right answer. Don't let other stuff bug you. But that takes some practice. That's why I want to show you, if we have time today, what it looks like when you look at the multiple choice. It can kind of throw your eye off, even though you've got the right answer, you know. So number 3, sine inverse of negative half. So I'll just write it up here. Sine inverse negative half. So you just look at the unit circle. Remember as you go around. Oh yeah, okay, so remember the quadrants. Do you remember the limiting stuff? Let me help you with that. That's another good thing behind your 3x5 card. These two quadrants for sine inverse and tan inverse. Remember? From negative pi over 2 to positive pi over 2. And you got to say the answers in quadrant 4 is negative. Remember that? And then over here is the two quadrants for cosine inverse from 0 to pi. Remember, that's a lot to remember, huh? So I say math, you just got to, I did too, you have to spend hours. You have to pour your life into it and go over and over and over and over and over and over and over these problems. There's all kinds of little facts and tricks and things you got to know. So, all right, so there's the restrictions for sine inverse, tangent inverse, and cosine inverse. So that means when I'm looking for an answer back over here for sine inverse, I'm only going to look in these two quadrants, right? Only going to look there. So where do I see negatives? This is cosine sine, cosine sine, cosine sine, cosine sine, cosine sine, cosine. Oh, there it is. Sine negative a half. So 11 pi over 6. So is that my answer? Remember, in this quadrant, you have to give it as a you have to say how much negative it is. That's just the way they set up the inverse trig functions. So you can't say 11 pi over 6. You have to say it as a negative angle. What is it as a negative angle? Negative pi over 6. You all okay with that? Because it's 11 pi over 6. It's 1 pi over 6 down, isn't it? So it's negative pi over 6. If you want to write these in, you could do that. You know, like if you want to just take your unit circle and put the negative versions, like this is the same as negative pi over 6. This one's the same as negative pi over 4. This one's the same as negative pi over 3. And this one's the same as negative pi over 2. You want to write that down? You could just do that. That's their negative versions for when you need those, right? Those spots. That's their negative versions. All right, so we have to give the answer negative pi over 6. That's where the sine is negative a half. So it's negative pi over 6. Good? Makes sense? Questions on that? Okay, so there you go. Try that one. See if you can find tan inverse of root 3 over 3. So remember, for tan, you got to think about sine and cosine, right? Because that's tan, sine over cosine. Tangent inverse root 3 over 3, how do you get that? So you got to think about sine over cosine. How can sine over cosine be root 3 over 3?
Multiplied by 1/2 over root 3 over 2.
Exactly. Yeah, how'd you know it was that?
I don't know. I just tried it.
Just came to you, huh?
Yeah.
Yeah.
Well,
Good.
you've done it before, and I remember it, so I tried it right now.
Yeah. What? Somehow. So basically, you need to realize that the way they're getting root 3 over 3 with sine and cosine is it's some combination of a half and root 3 over 2. They put one of them over the other, and the twos canceled, and they got the root 3 thing. So that's what needs to occur to you first off, is how they got that. Because tan is always sine over cosine, right? And so they must have done some kind of combo with the root 3 over 2 and the half. Well, how do you know which way they did it? Well, remember the trick I showed you before? Root 3 over 3 is really a root 3 in the bottom. They just simplified it. What do I mean? Take root 3 over here for a second. What that really is 1 over root 3, and they just multiplied top and bottom by root 3. Do you see that? So you need to go to there and go, okay, so really the root 3 is in the bottom. So this guy's on the bottom. So really it's a half over root 3 over 2.
And you know it's going to be in the top because there's no negative.
Oh, right, good. We'll get there, yeah. So everybody good with this part so far? Is this making sense? Right? So I look at that root 3 over 3. I think, okay, no, that's really 1 over root 3 that's been cleaned up, right? They just multiplied top and bottom by root 3, and then it became that, right? So it was originally 1 over root 3. And why does that matter? Why do I care about what it was originally? Well, because that tells me where the root 3 goes. The root 3 goes in the bottom. That's where it really is. It's in the bottom, right? So in other words, if you flip that thing up, right? Remember, you grab the bottom, flip it up, division's upside down, multiplication. You'll get that. You get 1 over root 3, won't you? So you see how that's right? So then I go, okay. So I'm looking for where is the sine a half, and simultaneously, cosine's root 3 over 2. Cosine, sine, right there. Sine's a half, cosine's root 3 over 2. It's pi over 6. There it is. Yeah, and like Chanel said, it's the first quadrant, because positive, right? Everything's positive in the first quadrant. So it's pi over 6. Pi over 6 is where that happens. So the answer is pi over 6. That's the angle at which that happens. That's what they want. They want the angle, don't they? Good there? Questions on that? All right. Okay, so try that one. See what you can do there. Give you a second on. That's got to be in your organization file. You've got to put somewhere in your mind or on your 3x5 card that if they mix functions and one of them's inverse, that's the draw the triangles. Because it won't say hint draw triangles. That part you got to know. So just make a note to yourself, or that's what I mean by people that do well in math science. They have their thoughts organized that way. Right? So there's a difference between doing homework, which is good and important first step, and getting ready for an exam. There's more steps, right? There's taking all that information and organizing it very clearly in drawers in your mind, right? You got to take all that information and put it in nice files and say, okay, when I see a mix, when you've got a regular and an inverse mixed together, that is draw the axis system and make the triangle kind of thing. You need to know to do that. So, all right. So that's what we got to draw when you see that. So, okay. So the first thing to figure out is which quadrant's it in. Let me give you a second. So you got in. Correct. You know how do you know? Well, it's starting here. It's tan inverse. Where's tan inverse? According to that little thing I just wrote there. It's one of these two. And remember, everybody's positive in the first quadrant, right? All students take calculus, they're all positive in the first. So all the inverse, remember we talked about all the inverse trig functions, all use the first quadrant, don't they? See how both cosine inverse and sine and tangent inverse are all using the first quadrant? That's because that's where everything's positive. And so that means they all use the first quadrant and one other, don't they? Well, that other's where their negative values go, huh? Right? So what? Well, in our case, we're talking about tan inverse of something negative, so we're in the fourth. We're in the fourth quadrant. Right? Tan inverse of something negative. We're down here in the fourth. So draw a triangle in the fourth. Always go to the x-axis. Right? Okay, good to there. So now what? So we're in the fourth. There, put your angle theta there. And so, remember, SOHCAHTOA. And tangent is opposite over adjacent. So this must be opposite and adjacent, huh? Good. So this is the opposite side. This is the adjacent. This is the hypotenuse. So the opposite is the 5. The adjacent is the 8. One of them is negative. It's right and down. So the 5 is negative. But if you want to just ignore that till the end, you can just skip the signs. Good so far? So now, How do we find the hypotenuse? Pythag, you know that. At this point, you're rolling, right? You know all this stuff. Just get through all that initial stuff. That's probably the hardest part. So that'd be 8 squared plus negative 5 squared is c squared. 64 plus 25 is c squared. 89 is c squared. Root it. So there it is. It's the root of 89 is the hypotenuse. We're ready to finish the question now. So what's the answer? They want cosine. What's cosine? Adjacent over hypotenuse. Adjacent over hypotenuse. 8 over the square root of 8. Oh, we can't keep a root in the bottom, so I have to get rid of that. Good so far. Now, is it positive or negative, though? Please be careful with your signs on this. It'd be a bummer, wouldn't it? I feel bad for people to do all this good work and then just get the sign wrong. Really pay attention to your signs. Really pay attention to your signs. So how do you know? Remember, you have the all students. This is what my daughters did 2 years ago when they took this stuff. They just, they didn't like all the signs. They thought there was too much to worry about. So they would just do the all students take calculus at the end. Double check that. It might be a good idea. So we're in the fourth quadrant. We know cosine's positive. So our answer's got to be positive, so we're good, right? You can always do a final double check on your sign with the all students take calculus. Do that. Do that. You wouldn't want to do all that good work. Every exam, I have many students who miss 2 or 3 questions just because of signs. That's a grade. You know, that's too bad. So double check your signs. Cosine. So you got to get rid of the root from the bottom. Root 89. So what is that? That's 8 root 89 over plane 89. Done. Good? Remember all that? So if they mix them, you got to draw the triangles in the quadrant. No questions? Just letters. Cosine, sine inverse 5x. But by the way, when they give you x, just put it in the first quadrant, right? Because we don't know what x is. X is a variable. Could be positive, could be negative. We don't know. Just put it in the first quadrant. So just do the same thing. Just put it in the first quadrant. Okay. So you just draw your first quadrant triangle. And SOHCAHTOA. And sine. Sine is opposite over hypotenuse. So here's our angle theta. This is the opposite, adjacent, hypotenuse. So one of the tricks is, a lot of tricks probably, but one of the tricks is we need a fraction. So what do we do with that? We gotta put it over 1, huh? And this is opposite, and this is hypotenuse. Yeah, so if it's not a fraction, just put it over 1. So that's right. So opposite over hypotenuse. That good? Sine is opposite over hypotenuse. 5x over 1. Now, can you find the adjacent side? Pythag, right? The Pythagorean theorem. So I'll do it over here. A squared plus b squared is c squared. Which one's always the c? Hypotenuse. So 5x squared or just a squared, whatever. It doesn't matter which one's a and b. A squared plus 5x squared is 1 squared. So it's a squared plus 25x squared is 1. Is that okay? You're squaring the whole 5x, huh? And then just jump that over. Can I just skip a step here? 1 minus 25x squared, and then root it. There it is. So the adjacent side is the square root of 1 minus 25x squared. Can I just make that 1 minus 5x? Remember, you can't do that. With pluses and minuses, you can't square root the 2 parts. You have to just leave it that way. So, okay, so then what's my final answer? What do they want from me in the end? Cosine. Cosine is adjacent, so cosine is adjacent over hypotenuse. So adjacent over hypotenuse, square root of 1 minus 25x squared over 1. It's just the square root of 1 minus 25x squared. And again, it has to stay that way. You can't square root it when there's a plus or minus. Just leave it that way. We good with that question? So that's part 1. That's all no calculator at all. Can you do all that? No calculator at all? All right. Let me